Single and double-ended priority queues. This presentation delves into the fundamental concepts and implementation of single and double-ended priority queues, exploring their unique characteristics, operations, and diverse applications. Introduction to priority queues. Order, data structures, efficient access, versatile applications. Priority queues maintain a specific order based on the priority of elements. Efficient access. They offer efficient access to the element with the highest or lowest priority. Versatile applications, widely used in scheduling, resource management, and other domains. Firstly, you have to know what is queue. Queue is a data structure of collection of elements of same data type. If a element is to be inserted, then it will be inserted according to its priority. If the element is inserted first, then the element should be deleted first or removed first. Afterwards, we can add another element after the first element. First, we have to give the priority to the first entered ones, then the second entered ones. So here it follows the priority for the elements operations in priority queues. Insertion, deletion, and peak. Insertion, here we can insert an element onto the queue, maintaining the priority order. Delete, remove the element with the highest priority. Means if we want to delete a element, first we have to delete the element which is inserted first. So it follows the rule first in, first out. Means the element which enters the first will be removed first. Other operations like is empty, size, get min, get max is also used here. Put, remove min, remove max. Is empty checks if double-ended priority queue is empty and returns true if empty. Size returns the total number of elements present in the double-ended priority queue. Get min returns the element having least priority. Get max returns the element having the highest priority. Remove min removes the element which is having minimum priority and returns that element. Remove max remove an element which is having maximum priority and returns this element. Implementing single-ended priority queues. Array implementation, linked list implementation. In array implementation uses an array to store elements, require sorting after each insertion. Array implementation means it stores the elements of same data type. Linked list utilizes a linked list to store elements, allowing efficient insertion and deletion. Double-ended priority queue can be built from balanced binary search trees where minimum and maximum elements are leftmost and rightmost queues respectively. Generic methods of arriving the double-ended priority queues. Inserting an element depending on the number of elements already present in the interval heap. Following cases are possible: odd number of elements, even number of elements, deleting an element, min element, and max element. Comparison of array and linked list implementation. Features of array and linked lists. Insertion in array requires sorting. Insertion in linked list is efficient. Deletion requires shifting. In array, we have to shift the element after the deletion of the first element. Means the element which is after the first element should be shifted to the position of first after the deletion of the first element. In linked list, it's efficient. Memory usage in array, it is fixed size. In linked list, it's dynamic. Implementing double-ended priority queues. Single-ended and double-ended. Single-ended elements can be added and removed from one end. Means here element can be added from one end and it is removed from another end. Only one end is used for insertion and another end is used for deletion. Here the add in insertion cannot done by from the point where the element is been removed. In double-ended, it can be possible. Elements can be added and removed from both the ends, allowing for greater flexibility. Here, both the ends are flexible. We can add element in front also and in all rear also. Priority queues. Applications of single and double-ended priority queues. Task scheduling, resource allocation, event handling, prioritizing tasks based on deadlines and importance. Resource allocation, managing resources efficiently based on priority levels. Event handling, processing events order based on their processes. Applications like external sorting. One example application of the double-ended priority queue is external sorting. In external sort, there are more elements that can be held in the computer's memory. The elements to be sorted are initially on the disk and sorted sequence is to be left on the disk. The external quick sort is implemented using double-ended priority queue. If the next element is the smallest element in the DPQ, output the next element as part of the left group, and the TPQ output the next element as part of right group. Otherwise, remove either the max or min element from the DEPQ. DEPQ means double-ended priority queue. Output the elements in the DEPQ sorted order as the middle group, sort the left and right groups recursively. Time complexity analysis. Insert, delete, peak. Insert O log n for heap based implementations. Delete O log n for heap based implementations. Peak O1 for heap based implementations. Advantages and disadvantages. Advantages: efficient prioritized access, versatile applications, well-defined behavior. Disadvantages: potential for memory overhead, can be complex to implement. Single-ended priority queue. Advantages: simplicity, the implementation is straightforward, often based on a heap or similar data structure. Efficient operations, insertion and deletions, removing the highest priority can be efficient with the time complexity of O log n when using a heap. Use case ideal for scenarios where you can only need to access the highest priority or the lowest priority depending on the need. Disadvantages of single-ended priority queue. Limited access can only access or remove the element with the highest priority. If you need to access arbitrary elements, a single-ended priority queue is inefficient. No bidirectional operation. You cannot remove elements from the middle or back directly unless you build the queue. Double-ended priority queue advantages. Greater flexibility allows both the highest and lowest priority elements to be accessed and removed, providing more versatile functionality. Efficient extreme access supports operations like getting the maximum and minimum priority elements in a constant time. Two-directional control. You can manage elements from both ends, offering more control over the queue's operation, which is useful for certain scheduling or optimization problems. The disadvantages of double-handed priority queues are complex implementation. Typically, a more complex data structure is needed, leading to increased complexity and potential higher overhead. Increased space complexity. Maintaining multiple ends can use more memory, especially when managing pointers or multiple structures. Insertion and deletion complexity. In some implementations, operations like insertion and deletion can have higher complexity compared to single-ended priority queues. Conclusion and key takeaways. Priority queues provide a powerful mechanism for managing data based on priority with both single and double-ended variations offering distinct functionalities. Understanding their concepts and implementation allows developers to optimize various applications, prioritizing elements effectively between the two depends on the specific needs of applications. If you need simplicity and efficient for one end, go with the single-ended priority queue. If you need more flexible access to both ends, the double-ended priority queue is better choice, albeit the cost of added complexity. Double-ended priority queue, while more complex, offers greater flexibility by allowing access to both the highest and lowest priority elements. The trade-off is increased implementation complexity and potential overhead in terms of memory and computation. Single-ended queue is simpler and more efficient for scenarios where you need to manage access the highest priority element at a given time. It is ideal for applications where priority need to be processed in a strict order. However, it lacks flexibility and accessing or removing arbitrary elements within a queue. Thank you. Please like, share, and subscribe. Visit again.